Consider the experiment of spinning an equally spaced triangular spinner numbered 1, 2, 3 and tossing 2 coins. So we have to complete the tree diagram to show all the possible outcomes of this experiment. So the first part is done. We have 3 possible choices for the spinner. For the second part, coin 1, it's been partially done for us. We've got heads and tails, so you have to do the same for the other 2. Because even with spinner number 2, when you toss coin number 1, you have heads or tails. Same here with spinner number 3. With coin 2, same thing again. It's been partially done for us. We just have to fill out the rest of this. Because it doesn't matter if we spin the spinner or toss the first coin, you're still going to get either heads or tails on the second coin. So, if we've got our possible outcomes, we'll just follow what you see in the tree. For example, for this one, we've got 1. Next up we've got a T, and it goes up to H. So we have 1, tails, heads. And the next one's going to be 1, tails, and tails. Then we've got 2 heads and heads. And then it's going to be 2 heads and tails. Then we have 2 tails and heads. And 2 tails and tails. 3 heads and heads, 3 heads or tails, 3 tails or heads, and 3 tails and tails. So those are all your possible outcomes if you did a tree map like this. Now, how many elements are there in the sample space? Well, you can find that out right here. You'll have 12 possible outcomes. You can always draw all of these out, but that's going to take a little bit of time. The other way you can shorten this up a little bit is actually to use the fundamental counting principle. So we know we have 3 possible outcomes for the spinner. If you multiply that by the 2 possible outcomes in coin 1 times by the 2 possible outcomes in coin 2, then you're going to have a grand total of 12, which is what we found with the tree diagram itself. The question is all the outcomes equally likely? Well, each coin has heads or tails, and with a spinner, assuming that all the sides are equal, then yes, absolutely. These should be equally likely outcomes. So state the probability of obtaining a 3 and 2 heads. Well, we've got 3 and 2 heads over here. Seems to be the only one out of possible 12 outcomes. On the other hand, we have a prime number and exactly 1 tail. The only prime numbers here are actually going to be 2 and 3, so you can eliminate anything in 1. We want only 1 tail, so that would eliminate this one. Okay, we'll also eliminate this one right here, as well as this one, and this one. We have basically 2 heads and tails, 2 tails and heads, 3 heads and tails, and 3 tails and heads. So you have 4 out of the possible 12 outcomes that would match that description. And as always with fractions, you have to reduce. So that's a 1 in 3 chance.